pollution has become a worldwide preoccupation.
Belching smokestacks that long symbolized prosperity have now become a source of irritation.
The foul air that had come to be accepted as an inevitable part of city living has suddenly become intolerable.
America was once on a path toward environmental self-destruction. The Industrial Revolution left dirty air, environmental damage, and serious human health problems in its wake. Then, in 1970, the United States Environmental Protection Agency was established. Air pollution became one of EPA's immediate priorities. Decades of innovative research and discoveries by EPA and its partners have made our air cleaner, healthier, and safer. For centuries, populations around the world found dirty air to be undesirable. During the mid-20th century, industrial pollution was part of everyday life. Filthy skies were accepted as unavoidable side effects of a thriving economy.
When I was young, it was considered that dirty air meant food on the table.
Up until the 50s, most people didn't believe air pollution had significant health effects, or that if it had any effects other than the fact it was a nuisance that you had to tolerate to let the economy roll on.
I just knew that as a child the sun didn't shine for days at a time. The skies were often smoky, and there were times when you couldn't even see the river because there were big clouds of smoke covering everything.
Soot and smog may have been signs of financial health, but they also brought serious health problems to communities.
In 1948, at the end of October, the small steel town of Donora, Pennsylvania, was enveloped in a smog. It wasn't the usual type of fog. It was a combination of smoke and fumes from the coke ovens, the rolling mills, the steel mills, the many coal-fired stoves in the town. And the pollution sat like with a lid on a pot and didn't move.
The 4-day air pollution disaster killed 40 people and left half of the town's population with respiratory problems. Dirty air that plagued cities and towns through the 50s and 60s fueled public concern. Outraged citizens staged protests. Communities passed local ordinances in an attempt to curb air pollution. Congress was compelled to act. In 1967, the Clean Air Act was passed. 3 years later, major amendments to the act were made, and EPA was established. This laid the groundwork for national environmental regulations, including those for air quality. These were important first steps, but science was urgently needed. Since 1970, EPA researchers have investigated dangerous air pollutants and provided the scientific foundation for regulations and solutions to reduce them. One of the first air pollutants to be scientifically investigated by EPA was sulfur dioxide, a major contributor to acid rain. While industry emitted large amounts of sulfur dioxide and nitrogen oxide into the atmosphere, little was known about its ecological consequences. EPA research indicated that these pollutants fell with rain, affecting forests, contaminating and killing water bodies, and corroding structures and cultural artifacts.
Acid rain was something that increased people's awareness of how air pollution could affect the environment starting in the 1970s.
The scientific discoveries about acid rain led to regulatory action that significantly reduced the problem.
There was a combination of high emissions transported far enough to affect sensitive regions, and it was a big issue in the 1970s and 1980s, and it led directly to the Clean Air Act amendments of 1990.
But acid rain was not the only air pollution problem tackled by EPA scientists. Industrial accidents that release toxic gases drew public attention to hazardous air pollutants. EPA scientists responded by conducting experiments that showed serious health problems from exposure to these pollutants, affecting the lungs, brain, and heart. As science uncovered these health risks, more needed to be done to protect the public. In 1990, amendments to the Clean Air Act led to the use of state-of-the-art control technology to reduce these hazardous air pollutants. Amid efforts to study acid rain and hazardous air pollutants, EPA researchers also began rigorous investigation into another potential health threat: ozone. Ozone is formed when air pollutants are emitted from cars, trucks, and other sources, and react in the presence of sunlight.
Ozone many miles above us in the stratosphere protects us from solar radiation, but ozone down at ground level where we inhale it causes damage to our lungs.
Ozone is oxygen gone bad.
Initially, ozone was considered to be an urban problem. In cities like Los Angeles, concentrated traffic spewed massive amounts of car exhaust into the air. Later, as suburbs grew, the problem spread and ground-level ozone became a national concern. EPA scientists investigated. They found that breathing ground-level ozone could trigger a range of health problems, from minor throat irritation to reduced lung function and inflammation in airway tissues. As science revealed ozone's impact on human health, EPA regulators established standards to reduce ozone. High ozone levels in cities like Los Angeles began to decline. However, a new problem became apparent.
EPA researchers did a series of studies that asked the question, was it harmful for people to be exposed to these lower levels of ozone but for many hours? And the answer was it was. And as a result of that, EPA modified their standard to protect those people who were in cities that didn't have large peaks of ozone but instead had lower levels of ozone for many hours.
Today, EPA and its partners continue to research ozone pollution, including its formation, in an ongoing effort to protect the public from its harmful effects. In the 1990s, health researchers uncovered another airborne threat, which many felt had been solved with reductions of visible smoke and acid rain. This threat, particulate matter, also known as particle pollution, or PM, somehow appeared to be causing people to die.
So EPA rapidly turned its attention to studying these particles, not because all of the important questions with ozone had been answered, but more as a realization that for public health benefits, we really needed to understand whether particles were killing people, and if so, how.
Particle pollution is an airborne mixture of liquid droplets and particles of all sizes.
They range in size from 1/10 the size of a human hair to 1/10,000th the diameter of a human hair.
It was massive amounts of these small particles that contributed to unsightly white and brown haze that hung over cities and many of the nation's scenic areas in the 70s.
Visibility is one of those things that everybody can appreciate. If you can see it, maybe it's bad for you.
When regulations improved visibility through the next decade, many thought the particle problem was resolved. It wasn't until almost 10 years later, when new ways to analyze contemporary health data were developed, that the health effects of PM became apparent. A landmark study in Utah Valley alerted the world to the dangers of particle pollution. Researcher Arden Pope found that there were fewer deaths and hospitalizations when a local steel mill closed due to a strike. EPA scientists examined particles collected during this time and found that their toxicity was greatest when the steel mill was open.
The combination of the epidemiologic results and these experimental results provided quite compelling evidence that particulate pollution, at least in that specific environment, had real, measurable, observable effects on human health.
Meanwhile, EPA and partner scientists discovered that the size of particles and their deposition into the respiratory tract were directly related to their potential harm. The smallest particles had the most damaging lung effects and also caused heart problems.
We've come to realize that these aren't just lung effects, these are cardiac effects. And we had not appreciated prior to these studies that there were potential cardiac heart effects associated with air pollution.
These and other similar findings provided the scientific foundation for stronger PM standards that continue to have immense public health benefits. The Office of Management and Budget estimated in 2007 that the cost of cleaning up particles over the previous 10 years provides an estimated savings in terms of health impacts between $4 and $40 billion a year.
All regulations pale by comparison to the impacts, the benefits associated with PM.
The science shows that reducing airborne PM improves health. A seminal study partially funded by EPA and published in the New England Journal of Medicine in January 2009 found that the cumulative efforts of EPA's air quality research and regulations increased the average U.S. lifespan by 5 months.
It turned out that cities that had larger improvements in their air quality also had relatively large improvements in life expectancy, even after controlling for socio-demographic variables, smoking, and other variables.
One of the biggest remaining research challenges for EPA scientists is to understand pollution mixtures in the atmosphere, which can contain thousands of chemicals.
So it's time that we start to look at the multi-pollutant environment, which is very difficult because, as you might suspect, when you talk about multi-pollutants, you can change one and you have a new mix. So you have an infinite number of combinations.
EPA scientists are beginning to explore the nature of these mixtures to see if they pose even greater health risks than individual pollutants alone. A new series of studies underway by EPA adopts this multi-pollutant approach by investigating the health impacts of living and working near busy roadways. The multi-pollutant approach requires collaborative research across scientific disciplines, from physics and chemistry to biology and ecology. EPA is also working to incorporate social sciences into air science, a necessary step in achieving sustainability. Multi-pollutant research will be vital to tackling a new and pressing issue: climate change and its interaction with air pollution.
There's plenty of evidence to show that climate change is upon us and it will continue to change. Well, that changes the dynamics of the multi-pollutant environment.
EPA scientists have already provided evidence that future temperature increases will raise air pollution levels in some parts of the country. But there is more work to be done. Air pollution research is needed to address climate change interactions, pollution mixtures, and other complex air quality problems we face today. As we strive for a sustainable future, EPA will remain at the forefront of air pollution research, investigating problems, creating solutions, and providing the tools and data needed to protect the air we breathe.
It's fair to say that EPA and related research that helps us understand the effects of air pollution does impact human health. It has saved lives and will continue to do so.
I think every American should know that air pollution is not required for our economic health. We're very fortunate as a country to have the EPA, which is helping us inform our regulations with good, sound science by their own internal research and the extramural research that involves the best researchers in the nation.